What if the tiniest particles in the universe could teach us about the largest mysteries of reality? A groundbreaking experiment is pushing the boundaries of quantum physics by proving that even everyday objects might one day exhibit quantum weirdness. But here's where it gets controversial. Could the laws governing atoms and subatomic particles actually describe the world we see around us? This question has long divided physicists, and a recent breakthrough might finally offer clues. Let's dive into the science and the debate it's sparking. For decades, physicists have known that quantum mechanics rules the atomic realm, while classical physics explains everything from falling apples to orbiting planets. But what happens when you try to blur that line? A team from ETH Zurich and Spain's ICFO has taken a bold step by demonstrating quantum wave-like behavior in nanoparticles, objects 1,000 times larger than atoms. Their work, published in Physical Review Letters, could revolutionize our understanding of reality and pave the way for ultra-sensitive gravitational sensors. The experiment focused on silicon nanoparticles, each 100 nanometers wide, about 1,000 times smaller than a human hair. These particles were suspended in a vacuum using a laser beam, a technique that allowed researchers to manipulate their quantum state. By cooling the nanoparticles to near absolute zero temperatures, the team extended their quantum coherence length, the spread of their wave-like properties, from 21 picometers to 73 picometers. To put this in perspective, imagine shrinking the Eiffel Tower to the size of a marble, and then asking how far that marble's shadow stretches. That's the kind of scale we're talking about. But here's the twist. Achieving this required a delicate dance with light. The researchers used laser pulses to create a trapping potential for the nanoparticles, similar to a marble rolling in a bowl. By adjusting the laser's power, they could control the bowl's depth, allowing the nanoparticle to explore more space and thus extend its quantum coherence. And this is the part most people miss. The real challenge wasn't just expanding the wave-like behavior. It was outpacing decoherence, the process that erases quantum effects by entangling the nanoparticle with its environment. Decoherence is the nemesis of quantum experiments. Every interaction with surrounding particles, like a stray photon or vibration, messes up the quantum state. The team fought this by reducing laser power during critical moments, minimizing scattering that would otherwise mess up the nanoparticle's quantum purity. We had to move faster than the universe's noise, says lead researcher Massimiliano Rossi, who now leads a lab at Delft University. It's like trying to balance a pencil on its tip while a hurricane blows. So, what's next? Rossi's team is already exploring hybrid traps that combine light and electric fields to further isolate nanoparticles from decoherence. If successful, this could one day lead to objects the size of a virus, or even larger, exhibiting quantum superposition. But here's a question to ponder. If quantum mechanics can describe a virus or a grain of sand, does that mean our classical world is just a cooler version of quantum reality? Or is there a hidden boundary yet to be discovered? The current 73 picometer coherence length is still tiny compared to the nanoparticle's 100 nanometer size. Yet Rossi remains optimistic. We don't see any reason why nanometer scale coherence should be impossible. This raises a provocative thought. Could we eventually create quantum states in objects visible to the naked eye? The implications for physics and our understanding of existence are staggering. What do you think? Is there a fundamental limit to quantum weirdness, or will it one day govern even the largest objects? Share your views in the comments below.